We had graphed that equation, and we had used the calculate menu from the graph portion of our calculator in order to find that maximum. That's what we're going to do here for the minimum as well. So on our graphing calculator, we've got that equation graphed in y equals. Type that in, and we've looked at the graph, and our interval that we're looking at is from -2 to +2. So we can see where we think the minimum is going to be, right? It's going to be, should be here at this point. We just need the calculator to tell us what point that is. Give us a little better estimate than what we can get by eyeballing it. So hit second trace to get to that calculate menu. We're going with option 3 for the minimum. And what's the left bound for us? -2. The first number that's in your interval is the left bound, so -2. The right bound, +2, the largest number in your interval that you're looking in to find that local max or min. So it's saying, okay, we're looking in between these two arrows, and it asks us to guess, and we actually do want to guess. We want to get, move our cursor as close as possible. So we're gonna hit the left arrow and get that down there close to where we think that minimum is at. And it looks like that's a little further down. So I'm gonna hit enter after I get close. And it's gonna get that minimum at +0.88, -3.12. That gives me, I'm just going 2 decimal places there because that's, I think, far enough. So +0.88, -3.12.
Good morning, Please rise for the pledge of allegiance.
So finding the local maxes and mins. Remember, local means it's where? Close, okay? They're going to give you an interval to look at for local. Absolute max and min. If I ask you for an absolute max or min for that particular function, is there an absolute maximum for that? No, because this continues up toward positive infinity in the range. So there's no absolute maximum. And that's the difference in absolute maxes and mins and locals as well, is they don't have to have an absolute max or an absolute min, because this graph doesn't have an absolute max or an absolute min, but we can find local maxes and mins if they give us an interval out of that. So be mindful of that as you're looking at stuff. All right. A couple more things in this section and we'll be done. Average rate of change. Kind of review thing here, hopefully. When you see the words rate of change, what should you be thinking? Slope. That's exactly what that is. The slope of a line. Okay. So if we're going to find the average rate of change, the kind of the college way of saying that is delta y over delta x, the Greek letter delta. All that means is taking the change in y over the change in x. That's what delta in math means, is change. But this is the formula you'll see in your textbook, and it's kind of, it's confusing looking, but it really is just the slope formula. This is the one we've used for years now. At junior high, you start doing the slope formula. But f of b just means the y value when x is b. F of a means the y value when x is a, some other x value. And then here we're subtracting the x values. That's what that is. So what they're going to do is they're going to give you some sort of equation. And so we're here. Let's say we have f of x equals 2x squared minus 5x. And they want us to find the average rate of change for f of x over 1, 3. And that 1, 3 is an interval. Keep that in mind. They're giving you an interval to find that average rate of change over. Okay, you wouldn't find the average rate of change for the entire domain, unless the domain had two distinct stopping points on it. But they're going to give you an interval, just like finding local maximum in. They're going to give you an interval to look in. Average rate of change are going to give you an interval. If they give you an interval, what values are these? X or Y? They're X values. Okay, so we've got A or B from this formula up here, or X1 and X2 from the slope formula is what we've gotten from them in the interval. They gave us X values. That's the key here, that these are X values. You gotta know that they're X values. So in order to find a slope, we need X and Y values, right? So if we've got the X values and we've got an equation or a function, we can find the Y values to go with them, right? How do we do that? Plug them in. Yeah, you find f of 1 by plugging 1 in for x, working it out. And it'd be 2 minus 5. So f of 1 is negative 3. And then we find f of 3. 3 squared minus 5 times 3. So it'd be 9 times 2 is 18, minus 15 is positive 3. So these two things, this is the ordered pair 1, negative 3. This is the ordered pair 3, 3. Okay, that's what those give us, ordered pairs. With ordered pairs, we can use the slope formula to find that average rate of change, and that's what we want to do here, is find that average rate of change by using our slope formula. Y2 minus Y1, so I'm just going to start 3 minus negative 3 over 3 minus 1. So it's going to be 6 over 2, which would reduce to be 3. That 3 right there is our average rate of change. Okay. Average rate of change, the slope. Okay, got to have two ordered pairs to find a slope. So you're just going to take those and take the x values from the interval, plug them in, find the y values that go with them, and work from there. Okay, to get that ordered pair and get your slope. Okay, all right. Extending that a little bit, there's another thing that we need to find, and it's called a secant line. Something you don't see a ton in algebra classes, but you see it more in the geometry setting. Does anybody remember talking about secant lines in geometry? It's like only one section that you talk about it in, with circles. A secant line in geometry, you're usually talking about circles. A secant line is a line that goes through the circle and hits it twice. A tangent line only touches once, but a secant line touches twice. So what we're dealing with is a secant line through a function instead of a circle. So it'd be like a secant line going through a parabola or something like that. That's what we're going to be finding, is the equation of that line that goes there. Okay, so a secant line, it's going to be in that form, y equals mx plus b, that we're so familiar with, we've been using for years. And again, it's going to be given over an interval. Two intersection points. Okay. Secant lines have two intersection points. They're happening over an interval that you're going to be given. Okay, so that is going to be a given thing. Is that, and then you're going to find that equation in slope-intercept form. So, if that's to kind of save us a little bit of the extra work of finding that slope and all that stuff, if we had the same equation that we used on example M, so f of x is equal to 2x squared minus 5x. Okay. We've got that going on, and they want us to find the secant line over that same interval from 1 to 3. Okay. So find the secant line. That's what they want us to do. Well, we already know that we have ordered pairs that go with that interval. We know that if we did f of 1, we ended up with -3. And if we plugged in f of 3, plug 3 in for that, we got +3. So we've got these ordered pairs, 1, -3, and 3, 3. And then we found this slope in example M. That average rate of change is the slope of the secant line. They go together. Okay, and that slope was +3. Okay, that's what we've already done by finding that average rate of change over that interval. So this ties directly to that. The next thing to do is write the equation in slope-intercept form. So remember, slope-intercept form is y equals mx plus b. What parts do we know? We know m, right? Well, m's 3. And what do we have in those? And x. We got x's and y's. Those are ordered pairs, right? We just need to pick one of them to use. It doesn't matter which one you use. Just use one of them. I'm going to use 3, 3 because I can't screw it up then. I can't put it in the wrong spot. So if I use 3, 3, I'm plugging 3 in for y. There's my slope. And then I'm plugging a 3 in for x. So this is using that ordered pair. And I'm looking to find out what b is, the y-intercept of my secant line. Okay, so just work that out. That's 9 plus b equals 3. Subtract 9. -6 is equal to b. So the secant line is y equals 3x minus 6 out of that. So to find a secant line, you got to find an average rate of change. They're going to give you the interval to find that over. And then you've got to find out what the y-intercept is of your secant line using that slope or that average rate of change that you got. Let's do one more of those. A different equation, different interval, just to get that whole shooting match going. F of x, let's go with the parabola 3x squared minus 2x plus 3 over the interval from -2 to +1. From -2 to +1. Okay. And we want to find the secant line. Find the secant line. Okay, so what's the first thing that we do? Okay, so to find the average rate of change, what do we have to do before we can do that? Okay, so find the f of x, or the function value for the interval there. So f of -2, plug it in, work it out. You can do that by hand. You can use the calculator to do that. Doesn't matter. I'm just showing it here on the screen, how you're plugging that in. 4 times 3 is 12. Plus 4 is 16. Plus 3 is 19. So f of -2 is 19. And then we're going to find f of 1. So that's going to be 3 minus 2 is 1 plus 3 is 4. F of 1 equals 4. So we got two ordered pairs. How do we find the average rate of change? Well, can't do that yet. We got to use the slope formula before we can do the y equals mx plus b. We got to do this part first. So what's the y value? Which one are we going to start with? 19. I would start with 19 and say 19 minus 4 over negative 2 minus 1. That's going to be 15 over negative 3. The slope is negative 5. There's our average rate of change, is that negative 5. So I'm just labeling this so we know what it is. Now, we can use the y equals mx plus b. What's m? Negative 5. So we're going to plug that into place of that. And then we can use one of the ordered pairs for x and y. Which ordered pair do we want to use? 1, 4. It's smaller numbers, so that would be easier to use. So I'm going to use 1, 4. 4 for y, 1 for x. I'm going to wait on Emily to finish her phone conversation. Put your phone up. Extremely disrespectful. We're working this out. B is 9. So our secant line y equals negative 5x plus 9. Let's look at that on the graph to finish it off, just to show how that secant line is reacting with that quadratic that we had there. So I'm hitting y equals, and I'm going to graph that original function that they gave me, the 3x squared minus 2x plus 3. And then on the y2, I'm going to graph my secant line, negative 5x plus 9. Okay, so I'm graphing the original function and then the secant line as well. And just making sure they intersect. If they don't intersect in two places, then I messed up somewhere finding my secant line. And so this is a good checking place for you when you're finding secant lines. As graph the original, graph the secant line. If they don't hit twice, something went wrong. Okay, you made a mistake in signs or just misadded or missubtracted somewhere. Okay, let me hit graph. There's our parabola. And then there is that. I'm going to zoom out a little bit so I can see, make sure that they're intersecting twice. Yeah, it does intersect twice. Okay, right there, right there. At those same points that I used before. I could hit trace, and my interval was negative 2. Negative 2, 19. That was the right ordered pair for y2. If I press the up arrow, it swaps over to y2, and it's pretty close. If I go negative 2 there, there's negative 2, 19. And then positive 1, 1, 4. We'll swap over to that one and do positive 1, and it's 1, 4 there as well. So the same two ordered pairs on both of the equations. So we can see it intersecting twice. If it doesn't, something went wrong. You gotta check yourself, make sure everything went the way it should have. All right. That's the last thing in this section. It's had a lot of stuff in it, a lot of different things in it. Problems would be 237, 1 through 79, odd, obviously. And if you need to work on some even ones, you can to get a better handle on some of that. Writing the equations on lines, that's something you've done in Algebra 1, so it's something you May have not done in a while, but it is something you